Hello everybody, my name is Ashish. I have opened up Quartus II software which allows me to program this FPGA board, and through this board I can generate a UWB pulse. So let's begin with the Quartus software. I have created my folder. In that folder I've created a PLL Cascade folder. In that I've opened up this project. So this is a PDF file which stands for block diagram file, and the device which I'm working with is Cyclone 4E, and the number for that Cyclone device is EP4C22F17C6. So there are three PLLs which I've used in this project. As you can see, the input is the clock frequency, that is 50 megahertz, which is generated by this FPGA board, which is inbuilt, and I can use that frequency to run all the PLLs which I want to. PLL is a device that can be used as to generate different clocks with higher frequencies, with lower frequencies, and in this way I'm able to generate the pulse. So in PLL1 I've chosen this speed which it runs is 6, and the frequency of the input clock, as I said, it was 50 megahertz, and the output clocks are 10 nanoseconds with a 0 clock phase shift and 10 degree duty cycle. Clock C1 is 20 nanoseconds, 0 phase shift and 50 duty cycle. Clock 2 is 200 nanosecond and 0 phase shift and 10 duty cycle. These are the outputs of PLL1, and I finish and I create all the files which are needed to run, and I have ANDed two outputs of this PLL, C01 and C1, to generate an output Cout4. In this way I've created a PLL2 which has the same input frequency, 50 megahertz, and it has Cout, that is 1000 nanoseconds, 0 phase shift and 10 degree duty cycle. Clock 1 is 1000 nanosecond and 10% duty cycle and 0 phase shift. Clock 2, that is C2, has 2000 nanosecond and 10% duty cycle, and I've generated all my clocks from this PLL, and PLL3 is the last PLL which I'm using, and I have an output clock of 0.1 megahertz and a clock phase shift of -20 and duty cycle of 10. So I've finished my creation of block diagram file. Now I will show you the pin planner which you can use to get the outputs you require onto your oscilloscope. So I go to pin planner from the assignments menu, and then as you can see, OP2 is pin B12, which is indeed this pin, right, GPIO, that's GPIO 33, so which is positively connected to the oscilloscope, and the ground for this FPGA board is pin 12, which is this wire. So I've taken care of the ground. I close this saves automatically, so now, and then I have to run the simulation on Model Sim. So I open up Model Sim Altera. This is the page that opens up when you open up, and then I have to change the directory as into which folder I want to work with. So I will go to the files where I've created it, and I cleared a work library for myself by going to new library and create a work library, and it says it's already there, so I will compile, and the library exists, and I will compile the code, and I will double click on this file to open up the objects and wave, and then I'm adding these signals to my wave. And as I told you, I'm working with 50 megahertz, so I have to force this clock to be 0.02 microsecond, and I will run it for some time so I get an output. So I'm zooming out, and as you can see, we are concerned. I'm giving it a bit of we are concerned for this output here. And I'm giving another simulation. As you can see, this is what pulse we are required. This is the pulse what we need. Output OP2 is what we are concerned with. So from here, I would like to calculate the distance time between these two pulses. That is 10 microsecond. So this shows that the time between two consecutive pulses is 10 microsecond. That is what we want to achieve. This is the output on my CRO. As you can see, I've connected the probes onto the FPGA board, and this is the USB blaster which is used to program the board. So we can see on the oscilloscope that I've generated pulses, and each of these blocks 5 microseconds. So there are two boxes in between them, so we can say 10 microseconds. That through this we can say that the output which we have simulated and the output on the CRO looks the same. And I would like to conclude this video. Thank you everybody for watching this.